In this section we cover exit statuses or error levels as reported by commands that are run on your system. Now within the bash environment, all commands return an exit status. No matter what the command is, whether it's binary, ASCII text, homegrown, or otherwise, every command run within a Linux environment, in particular within the bash shell, returns an exit status. Now if you're unfamiliar with programming, exit statuses facilitate conditional programming. Without exit statuses, many of the decisions that are made by programs would be impossible. So for example, in order to run process number 2, a certain status from process number 1 may be required. So for example, you may have a chain of commands, and command number 2 or subsequent commands may be contingent upon the status that's returned by command number 1, or procedures in procedural programming. But in general, when we script using the bash environment, we tend to string together various commands. As you should know by now, Unix and Linux as a derivative consists primarily of many or a plethora of useful utilities, small useful utilities that all return exit statuses, and when stringed together provides a powerful programming environment. But without the exit status, many of the decisions that we make would be impossible. So let's show you what we mean. We'll open a shell and we will attempt to run a command, a successful command, and you'll see the exit status. We'll simply navigate into temp2, which is a good directory which exists on the system, and if you simply type echo $, the exit status of the most previously run command is returned. Now in this case it's returned as 0. Now you may think 0 from Boolean is equivalent to a false run or a false instance, but in regards to exit statuses, 0 is good. So typically when a program returns 0, you're in business, you're doing pretty well. In this case, we successfully changed directory into temp2, so we're able to return a 0 exit status. Now in regards to scripting, if you're wondering and if you're unfamiliar to programming and wondered how this applies, let's say for example you had a routine within a script that relies upon the existence of a specific directory such as temp2. So for example, step 1 of the script or step 1 of the procedure within the script could be to change directory into temp2, no differently than we did here at the command line. If temp2 for some reason, perhaps by the cause of someone else on the system, another administrator or user of a system, if temp2 is no longer existing or no longer in existence on the system, then an error level other than 0 would be returned, such as 1 or some other number. You could simply put a conditional or a check within your script that says if error level is not equivalent to 0, then perform some other action. So if we attempt to change directory into temp2 and it fails, perhaps email the administrator or perhaps note to a log file the missing temp2 directory. So that's the power of exit statuses. So in this case, we have a status of 0. Now, another thing to note is as follows. Once you've echoed the question mark variable, in this case, $? As you know, within bash, variables are denoted by the $, and then the name of the variable following. So the question mark is a built-in reserved variable. Once you echo it, the status of the particular variable changes to the most recently run command. So the first command run in this series here was to cd, change directory into temp2, which was successful and returned 0. However, by virtue of echoing the variable, the question mark variable, which stores the return value or the exit status, that in itself overwrites the value of the variable question mark. So in other words, the question mark variable is always changing, so you want to get its contents immediately after execution of a step or of a script or of a particular binary. So as soon as something runs, if you need the error level, get it right then and there, because otherwise subsequent commands will overwrite the question mark variable. So temp2 is successful, we've echoed, and if we were to echo it again, it's still 0 because the echo command successfully runs. Now remember, as I've mentioned before, echo is a built-in command. It's also a system binary, if the system binary were non-existent, then the built-in command would run anyway, and it takes precedence. So running echo should always work within your bash environment and should always return an error level of 0. Now, error levels are represented by an 8-bit range, which includes values from 0 through 255. Those values can be assigned to different incidences. So as you develop scripts, you can make use of any value from 0 through 255, for the most part any value, as return values. Now, there is a guide using the bash reference guide. If you go to GNU.org, you can look up the commonly used return codes or status codes, the exit status codes. You'll see the ones that are reserved, such as 126, 127, which we'll be showing you shortly. But in general, you can use pretty much any of the values from 0 through 255. Now let's attempt to run a command that does not exist on the system. So echo works. Let's try to do, for example, pzd. Now this is just a play on pwd for print working directory. If we run pzd, it'll fail. And if we echo $? You'll see we now have a return value of 127. Anytime you attempt to run a command which is non-existent on the system, such as pzd, a 127 is returned. This is one of the reserved error statuses or exit status numbers that's used within the bash environment, regardless of platform or operating systems. If you're running bash on Sun, for example, and you issued a command which was non-existent on the system, a 127 would be returned. This is good to know because when you're programming your scripts, you can write little hooks which say as follows: if error level 127, or if exit status, or if question mark. You're essentially testing the question mark variable. If the question mark variable is equivalent to 127, perhaps echo to the user command not found, or log to a file, or perform some other function that indicates to the user of the script that the command is non-existent on the system. So 127 is reserved, and there are others. There's also 1, for example, if a command fails to run. So if a command fails to run, you'll end up with 1. Let's show you what we mean. The ls command certainly exists. If we run ls, it'll list the contents of the directory, and if we echo the question mark, it returns 0. However, let's pass a bad value into ls, such as z. The ls option does not have a z argument. If we run lsz and we echo the question mark, look at the difference in the output. It's now set to 1. So by virtue of running a valid command with a bad argument, it returns 1. In other words, it failed. So the ls command attempted to run, but z was an invalid argument, so 1 was returned. So this could be another thing that you test for. If error level 1 on a particular command, perhaps take the proper action. So the command exists, the argument's invalid, and 1 sometimes is returned by proprietary programs to meaning other things. And sometimes what you got to look for as a scripter, especially when you're joining multiple binaries, multiple executable binaries and scripts from disparate vendors, etc., you need to look for the exit statuses that are published by the vendor, or the error levels, or the error handlers, so that you get a sense for the values that are returned, and you know what to expect, so you can program to the values that are expected. Most well-designed programs will publish exit statuses for the user, the end user, to make use of, so that you can essentially have intelligent scripts on your system. You don't want to run, you shouldn't run programs that don't return valid exit statuses. Excellent. So we have 0, 1, 127. There's another one, 126, which is special, which means you have permission problems. We'll show you how to create that sort of condition. We'll touch a command called bad, or touch a file called badcommand.shell.sh for shell. Now this file is not executable. By default, when you touch a file, it's not executable. We can LSL to show you. As you can see, it has read, write, read, no executable. Now let's attempt to run this particular command. We'll run badcommand.sh, and as you can see, it says permission denied, but the words permission denied doesn't mean as much as echoing the value of the question mark variable, which returns a 126, indicating that there were permission problems executing this particular command. Now we could flag badcommand.shell executable, and it would attempt to execute, although it contains nothing. But let's say, for example, another user on the system less than root, or a non-privileged user attempts to run a particular command somewhere on the system. A 126 could be something useful to parse for. Let's show you some other basic stuff. We can do an echo hello world. This is the classic program for all programming languages. And after echoing hello world, we echo the question mark, it's set to 0. We echo it again, it's still set to 0 because echo ran successfully. Also, another thing you need to keep in mind, there's a built-in command called exit. Now I won't type it here because if I do it'll exit the shell. What I'll do is I'll open a new tab and show you. The exit command allows you to tweak the exit status that's returned from a program. So in a script, for example, you can say exit or specify exit with a particular number 0 through 255 for a specific condition, and you'll see in more complex programming situations where a certain area of your script may run and you may want to purposely return an exit value other than 0, 1, or something else. So for example, you may want to say exit somewhere in your script 150, and then 150 means something. So you can test for 150 or echo to the command or to the shell, to the interpreter, or write to a log file error level 150 so that when someone interprets the file they understand that a 150 equates to some other condition. So exit statuses and error levels are important to understand. There is an 8-bit range reserved, 0 through 255. The first 8 bits are reserved, and you can use most of them. In general, 0 indicates that the command has run successfully, and you'll see when we program, we test for the presence of the question mark being 0 so that we know whether or not to continue. Now we'll be showing you in the command chaining section and the command lists section next how the exit status plays in regards to some of the other built-in shell functions such as running and or situations, multiple commands, command chaining, to show you how to make better use of exit statuses. And all throughout the product you'll see how we make use of the exit status that's returned from a previous command regardless of the scripting language that's in use.